Okay, so we're going to be calculating exponential models using spreadsheets, and this is our second method using the idea of a common ratio. And again, we have our white rhinos. It follows this set of data, and we have it on a spreadsheet as well. And so in this method here, what we're going to do is we've already figured out the a value is 2. We did that in the last video, and so our model fits this pattern here. And so our key is to find the b value, which is the key value overall. This here is our horizontal asymptote. And so the first step is to subtract, step 1 is to subtract away the asymptote. Well, if I subtract away 5 from 7, I get 2. 6 from 5, or 5 from 6, I get 1 and 20 and so on. But let's use our spreadsheet to do so. So what I'm going to do is I'm just simply going to go to the cell I want. And when I do a computation with my spreadsheet, I hit the equal sign. And I'm going to click on this cell, and I'm going to subtract 5, enter. And this time I'm going to use the autofill feature, and I'm just going to click on the button, and it will fill all the way. All of these values have been subtracted 5. Now, in the next scenario, what happens is, when we think about this, in order to go from 2 to 1, the premise of exponential is that it multiplies by a value of b. When it goes from 2001 to 2002, again, it gets multiplied by b. Each time it gets multiplied by b. So if I'm going to call this b1 and b2, so in order to go this first one, it's going to be 2 times b1 is equal to 1 divided by 2. So I know that b1 is equal to 1 divided by 2, which is this cell divided by the previous cell. When I look at b2, well, it's going to be 1 times b2 is equal to 20. And so b2 is equal to 20 divided by 1, which is this cell here divided by this cell here. And so I can use my spreadsheet to find out these values. So if I'm going to go click here, I'm going to go equal to, and just to make sure it is the 2001 divided by the 2000. So I'm going to equal to 1 divided by 2. Enter. And again, it suggests for me to fill all these values in. And so I'm going to do so. But I have to be careful of the fact that 2007 is missing. So when I go from, this is 19, because I subtracted 5, and this is 78. So when I go from 19 to 78, it's really gone 19, this is 2006, to 2007 to 2008. And it's gone times b, which I don't know this value, times b again to get the 78. And so it's really 19 over, or sorry, if I say 19 times b squared times b is b squared is equal to 78. And so b squared is equal to 78 divided by 19. And then I'm going to raise this to the power of 1/2 because my spreadsheet doesn't do square roots as well. It likes exponents. And so I have to compute this myself. And so this 2, though, comes from the 2008 subtracted 2006. So let's use our formula spreadsheet to do all that. So if I go to 2008, so if I double click on it, I can see that this is the one that's used in 2008 divided by the 2006. But I really need to add into this, I'm going to put it to the power of 1 divided by, and I'm going to use 2008 subtract 2006. And now it's going to be a formula. If I hit enter, I get 2 is my value. And if I drag this down, dragged it down too much, I drag it down and I get the same thing. Now, you'll notice that there's an error here. Well, if I double click on it, you can see it's trying to use this cell that's dotted in orange and dotted in blue. They don't exist. And because it always uses the previous or the next cell, this is going to be non-existent. So let's see. So now I'm just going to go and do the average, not average D, but just average of all these values here. So over here, down to here. And I get 2.88. And so when I look at that though, what do you notice about these values? What I notice is that this value here of 20 is crazy big. It doesn't fit the pattern. Because it doesn't even come close to fitting the pattern, I'm going to consider it an outlier and delete it. And so now I'm left 1.45994 as my estimate of the final 149. So 1.45949, so 146. So if I go here and look at it, if I plug it in, I can see that is my graph. And here was from method 1, the blue graph. So here are two different methods. In this particular case, the first method worked better than the second method, but that's not always the case, okay? And so there's just two methods to potentially find a good model for your graph. And so here is our B value, and using spreadsheets and this equal sign and formulas to really find to simplify our work and find our estimated B's. So here I get our 1.46. The last thing I'm going to talk about, and it's not one of the questions here, but what does this 1.46 mean? 1.46, well, it means that the poaching of rhinoceroses, the poaching is increasing by 46% per year on average, okay? So the 1.46 means it's increasing by 46% per year, the poaching, which is astounding and not very good for the rhinos.